Hi. The topic that we are going to run through is JK flip-flops using NAND gate. JK flip-flops are also basically known as SR flip-flop. When you consider SR flip-flops, when S is equals to 1 and R is equals to 1, the entire circuit falls under the condition of indeterminate, invalid, illegal. To overcome that particular condition, Jack Kilby invented JK flip-flop, wherein S is replaced by J and R is replaced by K. When you look into this circuit, there are 4 NAND gates present, wherein the first NAND gate has 3 inputs. The first input is J, the second input is taken from the clock pulse, and the third input is considered to be the output of 4th NAND gate. The output of 4th NAND gate is Qn complement. If you notice, the circuit connection goes this way, and I am writing here Qn complement. Considering the second NAND gate, first input is K, second input is the clock pulse, third input is taken from the output of third NAND gate. Third NAND gate output is Qn. So this Qn is taken as the third input. I'm noting it down here. Wherein this Qn complement and Qn remains static for all the 4 cases. Now let's move on to the latch part, that is third and fourth NAND gate. Considering the third NAND gate, the first input is taken from the output of the first NAND gate, and the second input is taken from the output of fourth NAND gate. Fourth NAND gate output is Qn complement. Qn complement considered to be the second input. So I'm writing Qn complement here. So considering the fourth NAND gate. Fourth NAND gate first input is taken from the output of the second NAND gate, and the second input is taken from the output of the third NAND gate, which is Qn. Qn, I'm writing it here. So this particular Qn complement and Qn remains static for all the 4 cases. Considering case 1, J is equals to 0, K is equals to 0 and clock pulse is 1. That is J is 0, K is 0 and the clock pulse is 1. Now let's see the output of the first and second NAND gate. Before we are proceeding with the first and second NAND gate, considering the NAND gates truth table, Y is equals to A is the first input, B is the second input. Both the inputs are multiplied and complemented. Now let's apply this logic for the first NAND gate. Considering the first NAND gate, the input is 0 and the second input is 1 and the third input is Qn complement. Reference to the expression, I am complementing all the 3 values. Any value multiplied with 0 is 0, and I am writing this complement as the same. 0 complement is 1. So the first NAND gate output is 1. Let's move on to the second NAND gate. The first input is 0, second input is 1 and the third input is Qn. Reference to the expression, I am complementing all the 3 values. Any value multiplied with 0 is 0. So it is 0. I am writing this complement here. 0 complement is 1. So the output of the second NAND gate is 1. Let's move on to the third NAND gate. I am considering the expression as the same. Third NAND gate output is Qn, that is equals to, the first input is 1 and the second input is Qn complement. So in reference to the NAND gates expression, I am complementing both the inputs. Qn complement into 1 is Qn complement. I am writing this complement over here. So the answer of this is Qn. Let's move on to Qn complement. The first input is 1 and the second input is Qn. Reference to the NAND gates expression, I am complementing both the values. Qn into 1 is Qn and I am writing this complement as the same. So if you notice, Qn is equals to Qn, Qn complement is equals to Qn complement. That means the entire circuit is under the condition of no change. Now let's move on to case 2. J is equals to 0, K is equals to 1 and the clock pulse is 1. When the clock pulse is applied, J is 0, clock pulse is 1 and K is 1. Considering the first NAND gate, the input is 0, second input is 1 and the third input is Qn complement. Reference to the expression, I'm complementing all the three values. So 0 multiplied with two values is 0 itself. I'm writing down this complement. 0 complement is equals to 1. Let's move on to the second NAND gate. The first input is 1. The second input is 1, that is clock pulse. The third input is Qn. Reference to the expression, I'm complementing all the three values. Qn, I'm writing down this complement here. So the first NAND gate's output is 1 and the second NAND gate output is Qn complement. Now let's move on to the latch part. Third NAND gate. Output I'm considering Qn. The first input is 1 and the second input is Qn complement. Reference to the expression, I'm complementing both the values. Qn complement into 1 is Qn complement. I'm writing down this complement. So the answer is Qn. So the answer of Qn is Qn. Let's move on to Qn complement. The first input is Qn complement. The second input is Qn. Reference to the expression, I am complementing both the inputs. If you notice here, law of complementary says that A into A complement is equals to 0. So Qn complement into Qn is equals to 0. I am writing this complement here. 0 complement is 1. So as Qn complement is equals to 1, Qn turns to be 0. Now if you notice, Qn is 0 and Qn complement is equals to 1. So the entire circuit falls under the condition of reset. Case 3, J is equals to 1, K is equals to 0 and the clock pulse is applied to the circuit. That is, J is 1, the clock pulse is 1 and K is 0. Let's move on to the first NAND gate. Input is 1, second input is 1 and the third input is Qn complement. Reference to the expression, I am complementing all the three inputs. 1 into Qn complement is Qn complement. I am writing down this complement. So the first NAND gate's output is Qn. Let's move on to the second NAND gate. The first input is 0. The second input is 1, that is clock pulse. The third input is Qn. Reference to the expression, I am complementing all the three values. 0 multiplied with any value, it is 0. I am writing down the complement here, so the answer is 1. First NAND gate output is Qn. The second NAND gate output is 1. Let's move on to the third NAND gate. I am writing down the output Qn. Two inputs I am considering. The first input is Qn. The second input is Qn complement. In reference to the expression, I am complementing both the values. If you notice here, again it is under the condition of law of complementary. So A into A complement is 0. I am applying that particular formula over here. So the answer is 0 complement. Qn is 1. Considering Qn complement, first input is 1, second input is Qn. Reference to the expression, I am complementing both the inputs. The answer is Qn complement. As Qn is equals to 1, so the Qn complement turns to be 0. Now if you notice, Qn is equals to 1 and Qn complement is equals to 0. So the entire circuit is under the condition of set. When J is equals to 1 and K is equals to 1 and the clock pulse is applied, in that case, Qn and Qn complements previous state and the answer is flip and flop, which is known to be toggle state.